In this video, I am going to explain you data transfer and copy instruction. So these are the instructions that are used for transferring the data from our source register to our destination register. The first instruction is move instruction. So in that move instruction, what is the syntax? We are writing here move, then destination, comma, source. So the contents of our source will be copied into our destination register. So the operation is our source data will be copied into our destination register. So in the example, what is given? Move bx comma 1234h. So whenever we are writing here move bx comma 1234h, so the contents of our source will be 1234 and the contents of our destination will be bx register. So the 1234 value will be copied into our bx register. So the contents of our bx becomes 1234h. Now in the second example, we have written that is move al comma 3000h. So whenever we are writing here move al comma 3000h, so this 3000h is the offset address and that is the memory location that is given. So here I am writing move al comma 3000h in our bracket. So bracket indicates that is the offset address and effective address. So the contents of our effective address will be taken. Suppose I'm writing here the 3000h and that is the location, and in that location the value is stored that is 12h. That is our hexadecimal value. And whenever we are writing here move al comma 3000h, so whatever the contents will be there in that particular location, that is 12h, that we are copying it into our destination register. So the contents of our AL will be 12h. Now the next instruction is move BX comma CX. So these are both are the register. So whenever we are writing here both are the register, that time our contents of CX will be copied into our BX register. So assume that our contents of CX is equal to 0102. These are the contents that are stored in our CX register, and whenever you are writing here move BX comma CX, that time our contents of CX will be copied into our BX register and the contents of BX will be 0102H. So this is called as a move instruction. Now the next instruction is exchange instruction. So how this instruction will be executed? Here we have written that is exchange destination comma source. So the destination and source, these contents will be copied to each other. So our destination will be copied into source and source will be copied into destination. So these values will be shifted to each other. So the source will be copied into the destination and the destination will be copied into the source. So here assume that the contents of our AX will be 90H. So we are writing here before exchange instruction our contents of AX will be 0090 and the contents of our BX will be 80H because we are writing here the move instruction. So whenever I am writing here the move instruction, our contents of 80 will be copied into our BX register. So it will become 0080H. So before executing this exchange instruction, the contents of AX is equal to 0090H and the contents of BX is equal to 0080H. Now what we have to do? We have to perform this exchange instruction. So after performing the exchange instruction, the values of AX will be copied into the BX register and the BX will be copied into the AX register. So here, after performing this exchange instruction, our contents of AX will be overwritten with our 0090 and it will become 0080H. And the contents of our BX will be, previously it is 0080. Now this value will be replaced with our AX register and it will become 0090H. So in this way, our exchange instruction will be executed. So this is the second instruction, that is data transfer and copy instruction. The third instruction is load effective address, that is LEA instruction. And here we are writing the 16-bit register as a destination and then our source value. So the contents of our source will be loaded into our 16-bit register. So here the contents of our source will be the effective address of our particular memory location. So in this example, what is written? That is load effective address bx comma array. Suppose assume that we have declared the array variable in our program and we have written array db, then 10 comma 20 comma 30. So how this value will be stored into our memory location? This is our 10, this is 20 and this is 30. Suppose our memory location starts from our address, that is 0000, then if it is a defined byte, if it is a byte, that should be value becomes 0001. Our value will be incremented with 1. This will be 0002 and this will be 0003. So what is the starting location of our array variable? That is 0000. This is the starting location of our array variable. So whenever we are writing here load effective address bx comma array, that time it will point to the starting location of that source variable. So our source variable is array and in that array the starting location is 0000. So our location will be pointed to the 000H memory location and that value will be loaded in our BX register. So here we are loading the effective address of our source register into our 16-bit register. So in this example, our 16-bit register is BX register and we are loading the contents of our array, that is the starting location of our array, into our BX register. Now the next instruction is push and pop instruction. So first of all, we will check what do you mean by push instruction and then we will go for the pop instruction. So the push and pop, these instructions are used for storing the data from our source onto the stack location. Whenever we are using the push instruction, the data will be copied into our stack location. And that time the stack pointer value will be decremented by 2 and our MSB of our data source will be stored into our stack pointer location and the LSB of our source data will be stored at our stack pointer -1 location. So these are the contents of our memory location. This is the 000 location and this is the 0001 location. The first byte, our MSB of our source, will be stored into our stack pointer and the stack pointer -1 will be our LSB of our source data. Now in case of pop instruction, we are writing the destination and that time we are incrementing that stack pointer value and that will be stored in our MSB of our destination. And in case of LSB of our destination, this value becomes stack pointer and that will be determined by our stack segment. And here we are incrementing the stack pointer by 2. So how we are incrementing and how we are decrementing? In case of push, we are decrementing, but in case of pop, we are incrementing. So suppose this is your stack and these values are stored like 2, 3, 4 in our stack. So these contents of our memory location will be 0000 and this will be 0001. This will be 0002 if it is a byte. And likewise, this result will be stored. These values will be stored. So all these numbers are stored in our stack. Suppose I am pushing one value into our stack into the location. That time our value will be supposed stored it is 5. So I'm putting the contents of our stack and we are uploading the data into our stack location. So that time you have to decrement this value by 2 because here this location will be decremented by 2 and that will be point to the particular memory location. And here I am incrementing the value of 1 because whenever we are pop up the value from the stack, that time you have to go with that incrementation process. So stack pointer will be incremented by 2 in case of pop instruction, and whenever you are performing the stack push operation, that time this data will be decremented by 2. So these are the data transfer and the copy instructions are available in our 8086 microprocessor programming.